This is the example problem from the back side of the projectile motion paper. The problem we're going to solve today is, imagine throwing a ball off the roof of this building. How much time will the ball spend in the air? How far out from the base of the building will the ball first bounce? The ball is thrown perfectly horizontally with a velocity of 10 meters per second. The building is 20 meters above the ground below. Start with a sketch. Now I'm going to fill in the important numbers given to us in the problem. Let's see, the ball has an initial velocity. And, oh yeah, we also know the acceleration vertically. And I'm going to choose that 0 is the height of the ball initially, and that the downwards direction is negative. That means up is positive. That means when we talk about how far the ball is going to translate downwards, it's going to translate downwards a negative displacement. So let me put that number in there negatively. Ball's going to go down. Okay. So let's see, what else do we have? The acceleration in the x direction is 0 because of what we learned on the other side of this page, that the horizontal velocity is constant, the vertical velocity is changing. All right, here's my suggestion for organizing your solution now. So let's zoom out a bit here. Right. Set up the page with a horizontal column and a vertical column. You're going to solve each part of the problem separately. With 2 columns established, now we want to fill in the important assumptions that projectile motion tell us about this ball being thrown off the roof of the building. First of all, let's go with the horizontal motion. The velocity is constant. That sets up that 10 meters per second. It's horizontal. It applies forever until the ball hits the ground. Now let's look at the vertical direction. In the vertical direction, the velocity is increasingly negative. The initial y velocity is 0. The acceleration in the y direction is known. And, oh, we also know how high up the ball is falling from. You'll note that when we go back to the original problem, it says how much time will the ball spend in the air? So let's tackle that first. So this ball is going to travel through a parabola-shaped motion and eventually hit the ground. It will actually spend the same amount of time in the air as if it were just simply dropped from that height. So a ball dropped from 20 meters high will spend how long in the air? That's an exclusively vertical motion problem. I've taken the I've taken the free fall problem and written the equation here in terms of the y direction. You'll notice acceleration in the y direction, initial velocity in the y direction. Time doesn't have a direction, so no subscripts there. What do we know here? Well, negative 20, 0, negative 9.8. Well, this term goes away, so and this is solvable. Let's see, 20 divided by 4.9. Let me resort to my on-computer calculator. That is about 4.1. Let's take the square root of that. I really should remember to bring my calculator for these videos. That is 2 seconds. It rounds off. It's actually 2.02 seconds. Remember the original assumption here that the ball falling straight down from 20 meters high will spend the same amount of time in the air as the ball projectiling, that's not really a word, but traveling along this parabolic path. They're going to spend the same amount of time in the air. That whole time it's falling towards the ground, it's also translating out horizontally. So the second question here is, how far out from the base of the building will the ball bounce? That's this quantity, delta x, which we don't know. Right? Where's it going to land? The eternal question here. So that 2 seconds that the ball spends falling to the ground is also the 2 seconds that it spends translating horizontally. So I'm going to take that number and bring it over to the horizontal portion of the problem. In 2 seconds, traveling at 10 meters for every second, how far will it go? And this is a slight restatement of the way that the equation is written on the front side of the page. I think what I had there is I have 2 different x's in the equation. Combine them together and you get a delta x. So it really is the same equation, just written slightly differently. How far the ball travels, that's the unknown. That's what we're solving for. 10 meters per second for 2.02 seconds. Let's see if we answered everything this was asked. How far out from the base of the building will the ball first bounce? About 20 meters out. How much time will the ball spend in the air? About 2 seconds. We've answered everything this problem asked of us. Here, let me scroll to where you can see the whole thing. If you want to pause the video and just study the solution, that could be useful to you. I encourage you to break your problem into a horizontal and vertical portion, and remember that the thing that links them together, the one quantity that links them, is time. Time is constant between the 2 halves of this problem. While the ball is moving down, it's also translating horizontally. Good luck and happy problem solving.